Yeah. Do you remember the basic nature of amines? Okay, first thing, basic nature. What sort of bases are they? Like Bronsted bases, Lewis bases. How do they show basic nature amines?
Ma'am, by donating an H plus. Sorry, by taking up an H plus.
Yeah. Yeah. They take H plus. That means they form what sort of bases?
Lewis bases.
Lewis bases. They donate their lone pair of electrons on nitrogen. Yeah. So you have R and H2, which is an amine. So this lone pair of electron plus HX or whatever it may be. Yeah. So this is basically reaction with the acid. So this lone pair of electron attacks the H plus. So I have R, NH3 plus, and then X minus. This is the kind of salt that they form. In water, the basic nature is essentially looks like this: RNH2 plus H2O. This is the equilibrium that's set up. So RNH3 plus OH minus. So you can figure out like the Kb, the dissociation constant base thing. Next, we had discussed trends, basicity trends. So if you were to compare an alkenamine that's aliphatic versus aniline versus ammonia, which is all hydrogen. So what is the order? Like which is maximum, which is minimum?
Ma'am, could you repeat that?
Yeah, alkenamine versus aniline versus ammonia. So alkenamine is like an aliphatic chain, RNH2. Aniline is
NH2 and a benzene ring, and ammonia as NH4. Ma'am, here the more number of R groups, the more basic nature of the compound, right? So alkenamine should be more basic, like most basic, and then we'll have aniline and then ammonia maybe, or the other way around. Because
so
of the
compare benzene ring versus hydrogen. So how is a benzene ring going to affect the basicity, like the ability to donate the pair of electrons versus just having plain hydrogen?
So due to the presence of the benzene ring, the electrons will undergo resonance, right? So they won't be able to, if they undergo resonance, then the H plus should be free to go, right?
We're talking about basic nature.
Okay, taking H plus, sorry.
Yeah, so like if you have a benzene ring,
then it'll be least basic, right?
Yeah, this is less available to be donated, so this is the least basic, and ammonia is somewhere in between both of these. Okay, so if you were to if you had to phrase it for a give reason kind of question, we have, so alkenamine has maximum basicity because of the plus I effect. So it increases like the negative charge. So this also electron donating, plus you have a lot of negative charge because of the lone pair. So it attracts the H plus easily enough. So this particular thing will be pushed towards the side. So plus I effect makes the lone pair more available. And this is minimum because again, phenyl ring minus I effect, it withdraws electrons, which is why phenol was acidic. So always associate electron withdrawing with acidic nature, electron donating with basic nature. Okay. So phenyl ring delocalizes the electrons. Makes it less available. Also, another reason is that when you look at the conjugate base with aniline, so conjugate base is this particular species, forms something like this. So this particular species has lesser number of resonating structures than aniline. So this is basically less stable because there's the number of resonating structures is less. So that's another reason. Conjugate base pH NH3 plus has lesser number of resonating structures. Okay, so these are like the main reasons why this is more basic, this is less basic. And ammonia is like between both of them. Like take that as a standard because like hydrogen is like kind of neutral. Then you add an electron donating group because of the plus I effect increases the basicity. And instead of hydrogen, if you have a phenyl ring that engages the electrons, like it delocalizes electrons, pulls it within the ring itself, so makes it less available, so basicity decreases. So if you have to write the order, you can write it in this way. So alkenamine greater than NH3, which is greater than aniline. This is the order. If you want to write it properly.
Yes, ma'am, done.
Okay. Dhriti and Shantanu.
Yes, ma'am.
Okay. Dhriti, once you let me know if you're done, we'll go to the next part. Dhriti? Dhriti, in case you're speaking, it's you are muted, so I can't hear you. Dhriti, are you online?
Yes, ma'am, I'm here. I just want to take my water. I'm sorry.
Achha. Okay. So you done or still noting?
Last point, just a second.
Okay. After this, we'll still stay in amines itself, but we'll focus on alkenamine specifically.
Done, ma'am.
So within alkenamines, basicity of alkenamines. So within alkenamines, we have different types, right? Like we have tertiary, secondary, primary. So तीनों में से which do you think has like maximum basicity?
Ma'am, the order for this also will depend on plus I effect, right? More the plus I effect, more the basicity.
Same thing, absolutely. So tertiary versus secondary versus.
So tertiary will have the highest basicity, followed by secondary, followed by primary, and then ammonia.
That is absolutely right, except that is true in the gaseous phase.
here there's that entire different phase thing.
So gaseous phase may, like, you don't have to consider anything else other than just the amines. So Ms. Gases, you're looking at individual molecules of that particular amine, then absolutely you have the plus I effect, tertiary, more basic than secondary, more basic than primary, and more basic than ammonia. All because of your plus I effect. Are like greater the number of alkyl groups, more is the plus I effect, makes it better, more like makes the lone pair of electrons more available. But in aqueous phase, like when you dissolve it in water, you have solvation effects to be considered. Okay. So in aqueous phase, there are two issues. Plus I effect, definitely that matters. Apart from that, the stereochemistry, which affects the solvation of the ions, that also matters. So it depends on two things. One is the plus I effect, which is the only thing in gaseous phase. Second is the solvation effect that comes because it is dissolved in water. And the third is steric effects. Okay, so again, stereochemistry matters because again, these two are kind of related to each other, solvation and stereochemistry. So going purely by plus I effect, it's the same thing, whatever you have in gaseous phase. Tertiary better than secondary, better than primary. But if you want to consider these two also, that happens when you dissolve an amine in water. Now, because like, so do you guys want to take a guess? Like steric effects though make sense, like it depends on how chaotic the structure is. More number of R groups like in tertiary means more steric hindrance, because R is not just single atom, it's like something like CH3 or C2H6, which basically surrounds this whole thing if you have to look at the structure. So getting to this pair of electrons gets more difficult. So because of steric effects,
It will be the opposite order,
yeah,
right?
correct. Now, what about solvation? Like, what do you mean by solvation? First, let's
So
get
that's when the amine will get surrounded by H2O molecules or something like that.
correct. Solvation
So,
happens for every ion, like even for cations, lithium, cesium, metal ions also. Anything you dissolve in water gets solvated. That's H2O molecules surrounding the particular ion. Okay.
and that will also make it difficult for the H plus to reach the lone pair on the nitrogen. So shouldn't it follow the same order?
Same as what?
Same as in the steric hindrance order.
Yes, but it's for a different reason. Like it's not steric hindrance in this case. In the case of solvation, right? Small size means it is more, so yeah, like indirectly because of steric effects, as I said, like both are related to each other. So if it is large, like if you compare a tertiary versus a primary, in the case of primary, it will be better solvated. So more polarity, so higher basicity. In the case of tertiary, again, like steric hindrance, it's not as solvated. So whenever you're looking at, this is a universal rule, solvation, small size is favored. Small size means more solvation. Okay. And steric effects may, other than, like just spatial this thing, this also affects the hydrogen bonding. So if it affects hydrogen bonding, it also affects how soluble it is in water. So if it is not as soluble in water, that in turn affects the ionization. If lesser number of molecules are dissolved, the ionization is lesser, which is why it is the reverse in because of these two. So whenever you're comparing a set of amines, you need to figure out like how dominant the Plaza effect is going to be, how dominant solvation is going to be, how dominant steric effects are going to be. So you need to like take it on a case by case basis. But in general, secondary is maximum basic in aqueous phase. So in aqueous phase, this is the order: secondary, followed by primary or tertiary, depends on the size of the R group.
So, ma'am, if the size is large, then which order will be followed? The first one, right?
No, if the size is small, if R is small.
Oh, if R is small, so if example, if it's a methyl group, then the first one. If it's a ethyl or a propyl group, then the second one. Just
Correct.
to give out. Okay, got it.
Yeah, because if R is small, both solvation and steric effects are like both of them add to the fact that it's like primary is much favored. But in the case of, but if R is large, these two are going to bring it down. So Plaza effect is the only one contributing. So that kind of affects it that way. Yeah. So secondary के case में it's that sweet spot between both Plaza and solvation and steric effects. Between primary and tertiary, you need to look at what alkyl groups are surrounding it. So if they are small, if it's just the methyl groups surrounding it, then primary will be greater than tertiary. And if R is large, if you have like if the primary also is like C5H something, then tertiary may you have like ethyls and all of that, then yeah, tertiary will favor, like it is going to trump primary. So take it case by case basis. First, you need to see which phase it's in. If it's gaseous phase, simple, you don't have to consider solvation and all of that. So it's just the Plaza effect you'll see. So tertiary greater than secondary greater than primary. So if it is dissolved in water, aqueous phase, then you need to look at, okay, what are the R groups surrounding the NH2? So secondary is always the greatest. Then whether it's primary or tertiary depends on how big the R groups are. In whichever case it's like smaller, that is favored. Okay. So hydrogen bonding, why this is important is, and because of this again further affects the stability of the cation that's formed, the conjugate ion. So this is all about basicity. So once you're done noting this, we'll look at reactions.
Ma'am, I'm done.
Oh, alkenamines ho gaya.
Done, ma'am.
Yeah, aromatic amines. This is, we've studied aromatics enough that you guys should be able to predict. So aromatic amines. So you have aniline, and let's say it is substituted. So aromatic substituted amines. So how is that going to affect the basicity? Let's say it is substituted by a random group E.
Ma'am, E again, whether it's an electron donating group or electron withdrawing group, will play a role in how basic it is, right?
Correct.
If it's an electron donating group, then it will be more basic.
Yes.
If it's an electron withdrawing group, it will be less basic.
There you go. And for acidity, it's the same funda. So if it is electron withdrawing group, higher acidity matlab decreases basicity. That's it. Yeah, that's all there is to it. Same as like till now we have seen acidity because carboxylic acid, phenol, all of them are more towards acidic thing. Amines NH2A, we're discussing basicity. So same vanda, just that it's reverse. Increases basic nature, matlab it decreases the acidity. Decreases basic nature, matlab increases the acidity. The same thing. Okay. Next few chemical reactions of amines, it's going to be the exact reverse of what you guys studied in the preparation methods. Preparation mein kya kiya? Like we took esters, we took amides, we took nitriles, we took each of these compounds, converted them to amines. Chemical reactions mein it's the reverse of it. So first one I can see is alkylation. Basicity is the first property. Second property, alkylation. So alkylation, like you've seen in Friedel-Crafts alkylation, any alkylation is basically adding an alkyl group to an existing chain or existing compound basically. Could be like aromatic ring, could be like a normal aliphatic chain, basically adding alkyl group in place of H. Yeah. So Friedel-Crafts alkylation mein, what did you use as a source for the alkyl group? Do you remember? Anyone? Jyoti, Ansh, Shantanu? Do you remember Friedel-Crafts alkylation first?
Ma'am, can I answer?
Yeah. Yeah, Ansh? If you don't remember, say don't remember, then Mitali will answer. Go ahead, Mitali. What
Miss, sorry. Sorry. What I was saying is, Friedel-Crafts alkylation, that is the replacement of aromatic proton with
Yes.
the alkyl group.
Correct. So benzene hai, yeah, toluene, whatever it may be, aromatic compound, you replace one of the hydrogens that is there here with alkyl group. So where is this alkyl group coming from? What reagent did you use in this case?
Anhydrous
An
AlCl3.
aldehyde.
Ansh, what did you say?
Anhydrous AlCl3.
Anhydrous AlCl3. Along with that, where is R coming from?
Alkyl halide. So AlCl3
Correct.
is will be the catalyst.
Yes.
Which
Anhydrous
will have
AlCl3 is absolutely right, but iske saath alkyl halide bhi chahiye. So this takes away the chlorine. So you have the R ready to attach here. Absolutely. Nice. Teamwork ban gaya. So in this case also we're going to use the like not anhydrous AlCl3 but the Rx part like alkyl halide to substitute this alkyl group that is required. Let's call this R dash H. RR. So what happens is again simple substitution reaction only. So you get R N. यहाँ पे ये वाला hydrogen के place में the R dash gets substituted. So you have NH R dash and HX. Okay, so this is like a general reaction. So this sort of reaction, like if you want to convert any primary amine into a secondary amine, can use this, do it. An example, let's say we start off with aniline. If I make it react with like a simple methyl iodide. If I heat it, what is the product that I will get? See, I'm not using anhydrous AlCl3. I'm just heating it with methyl iodide. Tell me what product I'm going to get, okay? This is option 1 or option 2. दोनों में से which product am I going to get? You can send it in chat.
Yeah.
You can answer out loud also, but send it on chat. Okay. Nice. Mitali got it. Vritti and Shantanu, you guys give it a try. Option A or option B?
Option B, ma'am.
B. I'm not heating it with anhydrous AlCl3, guys. Follows the same pattern of whatever template I've given here. So यहाँ पे where did the R dash go?
Then it will be A.
A is the correct option. Yeah. Okay. That's why I've given this example so that you don't get confused. So this is the thing that I get. Always substitution happens on nitrogen. Okay. So in place of hydrogen, you get this. So if I let this reaction continue, how many ever nitrogens are there over here? It's going to go on substituting. Like it's going to take another. If I pass in excess of the alkyl halide, then each of the hydrogens gonna get substituted. And CH3 taken twice turns into a tertiary amine. And finally, another mole of alkyl halide heated with it. Then I end up getting this sort of this compound, NCH3 taken thrice. So there'll be a positive charge here, I minus. So this sort of a compound where it's an ionic salt, clearly, because they have a positively charged ion and a negative, like an anion. So this is an ionic salt. And nitrogen, like there is no hydrogen attached to it. In fact, it has a positive charge. So this sort of a salt is called a quaternary ammonium salt. Quaternary ammonium salt. So primary is when you have one R group attached. Secondary is you have two R groups attached. Tertiary is all three R groups attached. Quaternary, like 4-degree, is when there's a cation, like there's another R group attached, 3 + 1, 4 R groups, and it end up with a cation. Okay. So when the reaction is allowed to go all the way up to this step, whenever it when this happens, that's called Hoffman exhaustive alkylation. Hoffman's worked a lot with amines. Pretty simple. Alkylation hai, because you're substituting with alkyl groups at each step. Exhaustive alkylation, because you're substituting every single hydrogen available and then some. Like you're plugging in every single, what is the, like you're substituting with alkyl groups to the maximum extent. So Hoffman's exhaustive alkylation is when it is allowed to convert to a quaternary ammonium salt. Okay, so these are like the main things. So this is the main reaction. Note that a hydrogen on nitrogen is substituted with the R dash here, and yeah, lone pair of electrons gets this R dash. And a special note about it is Hoffman exhaustive alkylation when it is converted into a quaternary ammonium salt. Okay, so once you're done with this, we'll talk about acylation.
Done, ma'am.
Awesome.
Yes, ma'am.
Awesome. Mitali, Ansh, let me know once you're done.
Yes, ma'am, I am done. I'm sorry, there was a squirrel on the window.
Ansh is also done. Cool. So alkylation is when you add an alkyl group in place of hydrogen on amine. What about acylation?
Ma'am, CH3C double bond O
Yeah.
Cl, or like basically an acyl halide.
Okay.
Bless you.
Thank you. So when you add an acyl group, so acyl group, as you said, it is RC double bond O. Usually halide, acyl halide, but otherwise like whatever, rest of the compound is here. So whenever you add this, it's called acylation, again in place of H, which is bonded to this hydrogen. Okay. What do you think would be good sources of this? Acylation ke liye, what all can you use?
Aldehydes, ketones. Not aldehydes, maybe ketones.
Aldehydes or ketones, again, is it easy to break the bond? CHO, like, again, you have studied that mostly because of that minus I effect, this lone pair of electrons migrates over here and they undergo addition reactions. It's very difficult to like break the bond between R and CO or H and CO, right? What species do you know? Like again, we've studied this in a previous chapter that has a bond breaking at this part.
Oh,
Double bond ke baad.
but wait, wouldn't that be Grignard's reagent?
Grignard में oxygen नहीं है ना?
No, there's no
Aldehyde
oxygen.
and magnesium. Think of compounds that contain RC double bond O and that can break off over here.
Carboxylic acids.
Acid derivatives, absolutely. Not acids themselves, but acid derivatives like acid chlorides, acyl
For
halides,
acid,
basically.
all salts.
Not salts. Acid chloride,
Okay.
acyl halide only, basically. Specifically acetyl halide, RC double bond O Cl. Cl minus can go easily, यहाँ पे positive charge आ जाएगा, that way. Then anhydrides, acid anhydrides. Do you remember structure of acid anhydride? RCO joined by an oxygen and OCR. And the third one is esters. So RCOOR. Okay. Note this down, guys. I'll be right back.
Done, ma'am.
Yes, ma'am, done.
And Shanti, you guys done?
Yes, ma'am.
Okay. So these are your sources. And this reaction, it's basically a nucleophilic substitution. So in this case, so like substitution means you're substituting the hydrogen. The nucleophile that you're substituting it is the acyl group. So each of these cases breaks down over here, and in all of these cases, you're going to get a nucleophile. So you substitute hydrogen in the amine group. So NH2 or NHR, primary or secondary. Tertiary may obviously there's no hydrogen, so that's not gonna happen. With the acyl nucleophile. Here. That's the thing. This an important factor for this reaction is that happens in the presence of a really strong base. So why do we need the strong base? This is to shift equilibrium to the right hand side. So I'll like once we see the reaction, you'll get to know. So what the pyridine does is it takes away one of the products. Okay, and in each of the cases, the product you get is an amide. So let's take what happens in a primary amine. So this is a primary amine, and so R dash C double bond O, let's say Cl. So this is an acid chloride. So the lone pair of electrons, so again, as always, there's going to be like a delta positive charge on carbon. Oxygen's gonna keep pulling on the electrons. It's gonna take this. So this pair of electrons attacks the positively charged carbon. So what you get? So in the presence of a base, so you get R, N. So the two hydrogens are attached here. There's a bond formed with this carbon. So there is R dash, there is Cl, and O minus, because these pair of electrons have gone over here. Then again, the like Cl is also pulling on these electrons. So again, so the Cl is the one that takes away the electrons. The double bond is reformed over here. So what happens is R. Oh, also once this donated the pair of electrons, there's a positive charge here. So nitrogen pulls on these electrons here. So you get R, N, H, C double bond O, R dash plus H plus and Cl minus. So Cl minus got out independently, H plus also gets out independently. They may form HCl together, but the base is required here. So in the presence of the strong base, like this base is required to take away the HCl that is formed. So that makes the equilibrium shift to the right so that the reaction can proceed. The product that is formed here, because there is an alkyl group on nitrogen also, this is called an N substituted amide. Okay. Strong base, usually what is used is pyridine is used, because this is again an organic base. NaOH also can be used, but thing is it needs to be quite strong. Okay. So you can see like nucleophilic substitution. So nucleophilic substitution is happening on amine. That's not on the other compound. No, acyl no. This would be acyl. Make it acyl group. No, I got it wrong. Like amine itself is the nucleophile that is attacking the acid chloride. One pair of electrons. Yeah. Acyl is not the nucleophile. Okay, I'll again, just like before, I'll give you guys a reaction. Tell me what is the product that is formed. So if I take aniline and make it react with, let's say, an anhydride, because second source. Base required, let's say I take NaOH this time. So tell me what product is formed. Like if you want, I'll have this thing displayed here. Let me know when once you guys are done noting this.
Just a minute.
So aniline plus acetic anhydride, base I've given is NaOH. So if you want the mechanism to be displayed, let me know. I'll go to the previous page. Otherwise, just give me the product. If you're typing on chat, you can shorten this to PH, capital P small h. So that's phenyl ring. It's a shorthand.
Ma'am, can we give the names on the chat?
Yeah. If you know the common name, IUPAC name, go for it. Otherwise, you can draw the structure. Either way works. Just give me the product.
Miss, the reactants are aniline and acetic anhydride, right?
Yeah, whatever I've displayed over here, this only.
Yes.
There you go. Yes.
Oh.
Ansh, yes. Ansh, can you give me the byproduct as well? Kriti absolutely got it correct. So Shantanu, you're the only one remaining. Send your answer. Yes, unsure. Shantanu, are you sending your answer?
I don't know.
No? Simple, like acylation here. So every time you see either ester or anhydride, like something with this sort of a structure, right? R, C double bond O and O. Then in place of one hydrogen, you have like the C double bond O attached. So NH2 will become NH. So in place of one of the hydrogens, you have C double bond O and whatever is attached to C double bond O, so CH3S में. And the rest of it, like यहाँ पे bond कट जाता है after C double bond O, and the rest of it forms an acid. Whatever hydrogen you took out of here joins this. So previous case में HCl था, यहाँ पे this is CH3COH. Yeah. So इसका नाम है, IUPAC name is N-phenyl acetamide or ethanamide. Sorry. Acetyl is common, ethanamide. Common name is what you guys have mentioned, acetanilide. Yeah, that's kind of it. So whatever, whether you take acid chlorides, acid anhydrides, esters, whatever it may be, the bond breaks over here. So this whole part is attached to the amine, the nitrogen part of the amine specifically. Rest of it all remains the same. Okay. Specifically, if there is like if you are introducing, so this is again a special thing. So if the R is equal to phenyl ring, so that is like if this particular thing, C double bond O, is introduced, then it is called benzoylation. So look at the spelling, it is benzoylation because this particular group is called a benzoyl group. Okay. Within this also, like this particular reaction, suppose you have C6H5 COCl plus CH3NH2, presence of NaOH, yes, because you need a strong base. You're introducing this particular benzoyl group, so you end up getting CH3NH CO C6H5 plus HCl. So this particular reaction is called Schotten-Baumann reaction. Specific cases, like in general, the whole thing is called acylation because R C double bond O is acylation. Specifically, if your R group happens to be a benzene ring, that's called benzoylation. And one specific case of benzoylation between methenamine and benzoyl chloride, that's called Schotten-Baumann reaction. This is benzoyl chloride. Okay, so this is all about acylation. Oh, almost there. So then we have carbylamine and identification.
Done, ma'am.
Okay.
Done, ma'am.
Ash? Ansh, go ahead. We're still noting.
I'm done.
Okay. The last one, carbylamine reaction. So carbylamine is also called isocyanide. So in this reaction, we're going to be producing isocyanides. So you have RNH2. Another special thing is only primary amines give this reaction. So you can use it to test for primary amines also. When you treat it with chloroform, CHCl3, in an extremely basic medium, alcoholic KOH specifically. So on heating this, you end up getting NC, an isocyanide, plus 3 KCl plus 3H2. So this particular thing like NC, you guys have come across it pehle when we were doing haloalkanes, I think, unka substitution mein. So this is isocyanide. CN is cyanide because it's essentially the same thing attached on a different atom. So this is called isocyanide. Or also called carbylamine. And carbylamine has a very foul smell. So if you see that this reaction has happened and you stinking up the place, then oh yeah, so this is a primary amine. So that's an important point here. Secondary and tertiary don't give this reaction. Happens only with primary amines, so can also treat it as a test for primary. So identifier is if you get that foul smell. So apart from this, if you want to know specifically between primary, secondary, tertiary, so we have two tests. I can see this nitrous acid, diazonium salt, and all you'll get. Oh, you also have aryl sulfonyl chloride, Hintsburg test. Okay. Two tests basically. Guys, let me know when you guys are done. We'll do the two tests. Then probably look at some questions just so you have that confidence, okay, what sort of questions we're going to get from this. And then we'll start TF. Coordination compound, sorry, not TF. Okay. Riddhi and Shantanu, yeah, let me know when you're ready.
Ready, ma'am.
Okay.
Yes, ma'am.
Ansh? No? Okay. So identify between primary, secondary, and tertiary. So the first major thing is with nitrous acid. You guys remember the formula for nitrous acid? Like, how is it different from nitric acid? So formula for nitrous acid. HNO2. Yes, forgot about it or what? Okay, HNO3 is nitric acid, HNO2 is nitrous acid. So depending on what type of amine you take, even like you can even differentiate aromatic amine in this particular test. Okay. So first is, what if we take an aliphatic amine? So aliphatic primary amine. So if I make it react with RNH2 and HNO2. So HNO2 in this case is prepared in situ, meaning like in the reaction itself by taking sodium nitrite plus HCl. So यहाँ से आएगा HNO2. So when you make it react, you get a diazonium salt. You guys remember diazonium salt?
Yes, ma'am. Benzene ring with the N and N plus Cl minus.
N2 plus. So you need that
N2
bond
plus,
between
yeah, sorry.
nitrogen and nitrogen. That's an azo compound. Diazonium salt. So ionic hona chahiye. So you guys have seen Sandmeyer's reaction mein when it's a benzene ring, but that's one case of it. Like R can be anything. So this particular structure is called a diazonium salt. So as long as you have this N2 plus Cl minus, so that's a diazonium salt. Okay. So again, this is an ionic compound, right? So when you do hydrolysis of this, like wash it off with water, shake it with a little bit of water, you end up getting ROH. So this is why, like when you take a benzene ring, that's a preparation method for phenol. So this R is a phenol. So ROH plus this nitrogen breaks off as N2 gas and HCl is produced. So you end up getting an alcohol. Okay, so what is the test in this is you see that a gas is bubbled. So nitrogen is released as gas. So if you see that there is a gas being released, like a brownish gas, like nitrogen gas has that quality. So if you end up getting an alcohol plus a gas being bubbled out of it, then you can be sure it's an aliphatic amine. You guys have done it for aromatic amine. So if you take aniline, for example, so benzene ring, NH2. So you need to take, again, same thing, HNO2 produced in C2, so NaNO2 plus HCl, Sandmeyer's reaction, whatever you guys learned there. Extremely cold conditions like 0 degrees Celsius, 0 to 5. Gives your benzene.
I didn't catch that. Could you try again?
So if you use benzene, you get benzene diazonium salt. Plus NaCl plus H2O. This is benzene diazonium salt. Yeah. So this is quite important because one, it's a test for amine. Another thing that this particular test is used, like why the nitrogen is important is, so quantitative analysis of how much N2 gas is evolved, you can figure out um, like the quantity of the amino acid and protein that is present in a sample. So amino acid, again, you can see it from the name itself that you need an carboxylic acid group and an amine group present in the same compound. So you make use of this amine group that's present, make it react with nitrous acid, see how much of this N2 gas is evolved, and then you get a quantitative estimation of that particular protein. कि कितने amino acids है, basically. Okay, so you can note it down. So quantitative estimation. So you estimate how much of this N2 gas is released, because always 1 mole of this amine, like if you have one amine group, you have 1 mole of the gas being produced. So use that ratio. So quantitative estimation of the nitrogen gas. So it's used in the estimation of the protein. Okay, so just make a note of this. So this, like, you treat primary amines, so aliphatic में primary amines with nitrous acid, you end up getting nitrogen gas being released. So this also hydrolysis करने पे you end up getting phenol and nitrogen gas being released. Okay. Now, what happens if I use it on secondary amines?
Ma'am, could you go back for a minute? I wasn't done
Yeah.
coming. Okay, just a minute.
Okay, let me know when you're done. We'll look at test with secondary amines.
Done, ma'am.
Yes, done.
Okay. Ansh and Shantanu?
Yes, ma'am.
Okay. Ansh?
Done, ma'am.
So in the case of secondary amines, so I have R, NH, R dash, let's say, treated with HNO2, write the structure. HNO2 is, you have NOOH. This is what it looks like, HNO2. So what happens is there is elimination of like single water molecule. So this hydrogen that's present on the amine along with this OH group. So what you end up getting is R, N, N double bond O, R dash P attached in एक nitrogen पे. So there is elimination of one water molecule. So again, in this case, you don't have evolution of nitrogen. So this particular product that is formed, it's a yellow-green oily substance. It's formed as an oily layer. इसका नाम है N-nitroso N-alkyl amine. So depending on the R and R dash that's present here. And because I'm getting something called a nitroso group, so this particular test is also called Lieberman's nitrosamine test. Okay, simple. So यहाँ पे ये hydrogen and this OH is eliminated as H2O, and whatever is the remaining thing joins up.
Could you take another example for this reaction?
So this is the common one that's taken. Methyl aniline, N-methyl aniline, sorry. So NHCH3 plus HNO2, the same thing. So this hydrogen and this OH group. So remove water. So you end up like the phenol group, yes, N here. So this N also has CH3 attached. So that will still be there. यहाँ पे hydrogen की जगह this group is being attached. So another N double bond O. Okay, so this is N-nitroso, N-methyl aniline. So this particular part, highlight. So this particular part is called nitroso.
Yes, ma'am, got it.
Okay, N double bond O. And because in the case of secondary amines, so two reasons for this, like why is it different from primary amines? One is that basicity increases because the number of R groups has increased. So also, like again, because of the R group, because of the steric, this thing favors an elimination reaction where water is lost here. That's like a major difference compared to a primary amine, which is why you have this. Okay. So nitrogen gas is formed. It means it's a primary amine. You have an yellow gray, like a yellow green oily layer formed in the test tube, no gas being produced. That means it's a secondary amine. Let's see what happens if it's a tertiary amine. Yes, was anyone still noting that down? Or should we start with tertiary amines?
No, ma'am.
None? Okay.
Ma'am.
Like tertiary amines, you have 3 alkyl groups attached. when I make it react with nitrous acid, what do you think will happen? Highest basicity. So in this particular case, you end up having like a normal acid base reaction. So you have R3N plus HNO2 minus. Okay. So, so this particular compound is called a trialkyl ammonium nitrate. Okay, nitrite, NO2 minus as well. So trialkyl, so it's like ammonium nitrate, except instead of all hydrogens, you have like 3 of these alkyl groups. So trialkyl ammonium nitrate. So what is the test? Is basically it like ionic compound form ho raha hai na? So this kind of dissolves in a solution of nitrous acid. So just summarizing nitrous acid test. So if it's a primary amine, ends up with N2 gas being released. In the case of secondary amine, you end up having like a yellow-green oily layer. Nitruso compound is being formed there. And in the case of tertiary amine, just dissolves to form a salt. Okay, so these are like in a nutshell, how do you identify them? These are the identifying things. What happens in the test tube? This is what happens. Why it happens is like the reactions that we just noted down.
Ma'am, we don't have diazonium salts in our syllabus, so this will be the last of it, right?
Yeah.
Okay.
So nitrous acid test. These are like the test results. So based on this result, you can figure out whether it's primary, secondary, tertiary. And then we have another test, aryl sulfonyl chloride, also called Hintsburg reagent. Okay. I'll give you guys the key for that also. So the kind of product that is formed is the same, like reaction is the same, but the behavior of the product changes between primary, secondary, tertiary. So that's like relatively simpler. Nitrous acid ke case mein, the reaction itself is different in all 3 cases. So you're getting 3 different kinds of products. Tell me once you guys are done, we do finish this.
Done, ma'am. May I go to the washroom?
Okay. Can you wait for
I'm
the
even I'm done.
Because
Yes,
once we're done with this, I'll give you guys like a 15-minute break and then we'll start the other things.
okay.
Okay. Anshantanu, shall we do the next test?
Yes,
Ansh
ma'am.
has replied. Shantanu.
Yes, ma'am.
Okay. Second test, 2 degree nice, sorry. So this is called Hensburg reagent. Chemically, what it is it's an aryl sulfonyl chloride. So name say you can figure out what the structure is. So aryl, you have a benzene ring. Sulfonyl, So you have like SO3H thing, double bond O. Sulfonyl chloride. Abhi carboxyl like acyl chloride hai, so in place of OH you have a Cl. Sulfonyl chloride mein again in place of OH, instead of it being SO3H, you have a chloride over here. So this is aryl sulfonyl chloride. Okay. So the reaction in all three cases is the same. If you have an amine, so R to chahiye, and then there's N. Now, depending on whether it's primary, secondary, or tertiary, either it's both H's or one of them is an R or both of them are an like R group hai. So whatever it may be. So I'll leave this bonds open. So if we have this reacting with our aryl sulfonyl chloride, let me do it. Let's write it in this way. Plus Rn, double bond here. What you end up getting is again, it's just like what you found during acylation reactions. This bond breaks and this gets attached to N, and like one of the hydrogens is lost. So if we have primary amines, this is what it ends up being. S double bond O, double bond O. In place of Cl, nitrogen, one hydrogen is lost, one is still left, and then you have R, okay, plus HCl. In the case of secondary amine, so you have R, N, this hydrogen is there, or let's put it over here. And then R dash. So a product is going to look very, very similar. Just that you're going to have alkyl groups on both sides. Now, case of tertiary amines. Now, because we don't like tertiary amines, we don't have the hydrogen here. This is not going to have any reaction at all. We don't have any product that forms. So this itself is the test. Like, agar reaction nahi ho raha hai, matlab it's a tertiary amine. Now, what's the difference between the product that is there in primary and secondary amine is that because this particular hydrogen, now sulfonyl is like extremely, it's an electron withdrawing group, just like carbonyl, carboxyl, all of these. So this particular hydrogen ends up being an acidic hydrogen, which means the compound that is formed with primary amines is soluble in an alkali, in a base, basically, in alkali, like NaOH, KOH, and all. But in the case of secondary amine, this will not be soluble in a solution of NaOH, KOH. So it's insoluble in alkali because there is no acidic hydrogen that's present in this. And in the case of tertiary amines, because there is no hydrogen present at all, there is no substitution reaction taking place, like elimination of HCl nahi ho raha hai. So there is no product being formed. So that's the criteria of this test. So the reaction is the same. The hydrogen, like one of the hydrogens, if there's only one, then that single hydrogen. Otherwise, one of the hydrogens gets replaced with this particular part, like just like our acylation reaction, yahan pe break hoke, this whole thing gets attached. Now, in the case of primary amines, because this hydrogen is there and then it's connected to N, it's connected to the sulfonyl group and aryl group, this ends up being an extremely acidic hydrogen. Acidic property matlab it will react with bases. So this is soluble in an alkali. In this case, because we don't have any acidic hydrogen, it won't like get neutralized with a base. So we say this is insoluble in an alkali. And in the case of tertiary amines, there is no reaction at all. Okay. Fun fact, we say aryl sulfonyl chloride, not this specifically, because another compound used like in place of this is you can also use a methyl substituted thing. Everything else remains the same, just that either this reactant or this reactant. It doesn't make a difference because the reactive site is essentially the same. You have an aryl group, you have this bond. And the reason why we go with an aryl group is because, again, aryl group, sulfonyl group, we want to produce this acidic hydrogen, which will not be there in the case of a secondary amine. That is the main point of the test. Okay, so that is it. Apart from this, we have electrophilic substitution. We have gone over electrophilic substitution like 6 times, starting with benzene and every single case. Just give me one thing. Electrophilic substitution of amines, is it orthopara directing or meta directing? And just let me know, guys. Once we're done with this, we're done with the chapter.
Done, ma'am.
Okay.
Done, ma'am.
Ansh?
Done, ma'am.
Okay. All right. So if I take aniline, aromatic compounds का speciality है ये, NH2, sorry, not 3. This on electrophilic substitution will give me orthopara directing or meta directing. Is NH2 electron withdrawing or electron donating? What sort of product will you get, guys?
Ma'am, orthopara directing.
Okay, that was Mitali. Dhriti and Shantini, you guys, do you agree? Or
Yes, ma'am.
yeah, absolutely. NH2 is electron donating, so this is going to be orthopara directing. So NH2 activates the ring. Yeah, that's it. So any other thing like acylation, alkylation, nitration, sulfonation, whatever reaction you make it go through, you get orthopara products. Okay. The time is 4:50. Let me stop this.